All right, so when simplifying rational expressions, the process that we want to do is look for that division property. All right, and there's a couple things that is important that I didn't really mention with this division property. That the division property works when we have an expression divided by an expression, but it doesn't technically mean we can't divide across addition or subtraction. So in the fact of here, like for instance, if I had x plus 3 divided by x plus 1, that does not equal 3 over 1. You can't divide out these x's when we have them separated here with addition and subtraction. So this only works when we have terms separated by multiplication. So when we're simplifying, what we want to do is make sure that we can rewrite each expression separated by multiplication. And the process of taking an expression and rewriting it as multiplication is factoring. So we're going to be doing a lot of factoring practice. So that's basically what we want to do is factor it and then look to see where we can apply the division property, because I cannot divide out these x squareds because all these terms are separated by addition and subtraction. So be careful with that. The first step you'd always want to do is factor. So factoring here, we're doing trinomials. What two numbers multiply to give you -4, add to give you -3. Let's see, we're going to have x minus 4 times x plus 1. In the denominator here, I can see a difference of two squares, so that's going to be x minus 1 times x plus 1. Now you can see these expressions are separated by multiplication, so therefore x plus 1 divided by x plus 1, that divides to 1. So technically what you have here is, x minus 4 divided by x minus 1, and then, times 1. Well, we don't really need to write the times 1. We can just know that the 1 is there without writing it. So typically we don't go ahead and write that. Now, also, another times we'll also talk about, writing the constraints of the rational expression. But we've already kind of talked about domain and how to identify, the values that are not, provided in the domain for this. So for these examples, I'm just going to work on simplifying the expression, not talking about the values. Obviously x cannot equal 1 or -1 in that expression. But for the rest of these problems, I'm just going to focus on the simplifying aspect, not so much as far as the values where x is undefined. All right, in the next one here, we see a trinomial. Now, I noticed that this is a perfect square trinomial, but you might just ask yourself your question, no, that is wrong. That's supposed to be a 2. What two numbers multiply to give you 2 and then or 4 and then add to give you 4? Well, that's going to be x plus 2 times x plus 2. Okay, in the denominator, sorry, I made a mistake there. What two numbers multiply to give you 2, add to give you 3? Well, that's going to be x plus 2 times x plus 1. 1. Now, it is important. We've already discussed, factoring a lot in my class. So if you're kind of falling behind or kind of wondering on the factoring, just remember you can always check my work by multiplying these expressions back to make sure you get the original problem. Okay. But again, here we can see that the x plus 1s or x plus 2s, I'm sorry, these divide out. That still leaves us with an x plus 2 over here, but that's okay. We can only divide one expression by itself, right? So therefore, that's going to leave us with a final expression of x plus 2 divided by x plus 1. The next equation. So now we have some fun stuff here. So over here, we have a trinomial with 2, but we can't factor out the 2. Now, one thing, we've been working on this in my class, but one thing I mentioned with the students is, just remember we can always rewrite a trinomial as a product of two binomials. Okay? Or a quadratic trinomial. And then we know the first two terms need to multiply to give us a 2x squared, so that's going to be 2x times 2x. And then they need to multiply to give us a 2. Well, our only options are positive and -2, right? I mean, that's the only option. It's either plus 2 and plus 1, or we could write this as 2x plus 1 and x plus 2. Because we can't do negative, we don't want to use negative because obviously the middle terms need to add up to give us a positive, linear term, right? So the 2x and the 2x, times 1 need to add up. Well, if you do the middle terms here, 2 times 1 and 1 times 2, they both give you 2. But 2 times x and then 2x times 1 gives you 4x, whereas here 2x times 2 is 4x plus 1 plus x is going to be 5x. So my first example is wrong. We want to use this one. And again, it really just kind of comes into a lot of practice, and that's why we've practiced that in my class, so we're prepared for it. Now, in the next example, I can see that they're all divisible by 2. So I'm going to factor out a 2 first, and then let's just leave that. Let's just factor out a 2 here. So if I factor out a 2, I'm left with x squared plus x minus 2. Okay, and then basically we're seeing what 2 numbers multiply to give you -2, add to give you a +1. Well, that's going to be an x plus 2 and then an x minus 1. All right, and now again, we can see that these x plus 2's are the same in the numerator and denominator. Notice here's a 2. I don't have anything with the 2 to divide out here, but that's fine. So we'll just leave that in the denominator. So therefore, my simplified expression is 2x plus 1 divided by 2 times x minus 1. All right. The next one, a lovely sum of 2 cubes. So that is one of those formulas that we, kind of discuss in class. And I really, I'm not a stickler on this formula because, it shows up every once in a while. It's important for students to, recognize when you see this relationship. So when we have a cubed plus b cubed, that's going to be a plus b times, let's see here, a squared minus ab plus b squared. So that's the formula for the sum of 2 cubes. The difference of 2 cubes, FYI, is very similar, but it's a minus b times a squared plus ab. So it's just kind of nice to know because these problems do show up once in a while. So I'd say it's, it's pretty helpful to just kind of have them. And if you work through a couple examples, I think that usually, satisfies with enough students. All right, so therefore I'm going to simplify this numerator here. So basically what I want to do is rewrite this as a cubed b cubed. Well, I can rewrite this as x cubed plus 1 cubed. So therefore I could say a is x and b is 1, right? You could think of this like a cubed plus b cubed. So a is x and b is 1, right? You can write this in that form. So therefore the numerator would simplify to x plus 1 and then times, let's see, x squared, and then minus 1 times x, so that'd be negative x, and then plus 1 squared, so that'd be 1. And then in my denominator, you see I can factor out a 3x. So by factoring out a 3x, I'm left with a x squared plus 1. That's not what I wanted. That was supposed to be a squared. Man, I messed up because we don't want that to be a plus 1. That'd be x squared plus 1, right? Yeah. So I think actually what I wanted this to be was to be a subtraction. So I'm going to change that problem. So let's make this into a subtraction problem. Sorry, I'm just working through this. My first time going back through. I thought I had these checked. So that's going to be a x squared minus 1, or I typed it in wrong. I'm not really sure, but I think this was supposed to be an x squared minus 1 because what you see is nothing can divide out. Now, this is a non-factorable trinomial. I can't factor this out. And there's no point in using quadratic formula because we're not trying to solve. We're trying to rewrite this as factoring. However, this can be rewritten as x squared minus 1, or x minus 1, x plus 1. So if I kind of rewrote that as x minus 1 times x plus 1. Now what you can see is these now divide out. So therefore, I'm left with a simplified answer here of x squared minus x plus 1 all over, still have that 3x times the x minus 1. And you can multiply that through or leave it in factored form. It really kind of depends on your teacher and what kind of like the question is. Next example. So now we're going to get into some higher up polynomials factoring. So, just to kind of have a little fun here, just to remember these factoring techniques. So remember what we can do is we can treat this, it's not equal to, but we can treat this like an x squared minus x minus 6 and say, what 2 numbers would multiply to give me -3, add to give me a -1. And if I was going to think about that, I would say, well, that would be x minus 3 times x plus 1. No, x plus 2, right? However, this times this gives you that, and we need this times this to give you this. So basically, all I need to do is raise the powers here of x squared minus 3 and x squared plus 2. On the same set, I want to think of this as a difference of 2 squares. So rather than, if I was going to think of this as an x squared x squared minus 16, I would say, oh, that's a difference of two squares. That's basically, if I was going to factor that, that is x minus 4 times x plus 4, right? But again, I need x minus 4 times x plus 4, not to give me x squared minus 16, but to give me x to the 4th. So therefore, I'm just going to raise the powers again. Now, again, what we notice is I can further simplify down this x squared minus 4, and actually, even if I factor those down, nothing is actually simplifying out anyway. So I'm not sure maybe if that was my problem or not. I think so. But either way, I don't think there was actually a mistake on this one. I think I was meant to have something that doesn't simplify factored out. You can't actually simplify this out. This is actually in your simplified form. Now, you could try to further factor like this down into, you know, x minus 2, x plus 2, but the thing is that this isn't going to factor out any further. Like, you know, if you factor that down to x minus 2 times x plus 2, what you can realize here is these aren't going to cancel with anything, you know, or divide out with anything. So that is your simplified result. Moving on to the next one. So here what we have is a couple different things. Now we have a polynomial with 4 terms, and then we have something that looks a little bit different than what we're used to. So the first thing that I would do in the denominator is I would rewrite it like with the x in front. And if I rewrite it with the x in front, I have a negative x plus 1. Okay? And I don't really like that, right? So typically what we can do here is we can also, well, let's get to that in a second. To factor this, what we're going to want to do is group the first 2 terms and group the second 2 terms. I'll come back to this denominator. All right, so by grouping, now what we're going to do is look to factor out the GCF of each grouping set. So here you can see we have x cubed plus 4x squared, so therefore I can factor out an x squared. By factoring out x squared, I'm left with an x plus 4. Okay. Over here, I want to factor out a term that I'm going to get an x plus 4. Well, that's going to be a negative 1. By factoring out a negative 1, I get an x plus 4. And then let's rewrite that over negative x plus 1. All right. Now, again, we'll come back to this answer. Now, here you can see that both of these expressions have in common an x plus 4. So I'm going to now factor out the common x plus 4. And I'm left with a x squared and a negative 1. So that's going to be an x squared minus 1. And if you're still kind of confused with this, multiply the quantity x plus 4 times x squared, multiply the quantity x plus 4 times negative 1, and you get this exact result. Now, again, on the outside, I'm not seeing anything dividing out, right? But I can simplify this to x squared minus 1. So I'm going to do this one more time. So let's do, so that equals. So if I do this x plus 4, and I factor this out into a x minus 1 times x plus 1, well, this is very similar to right here, right? So if I want these to be the same, what I can do is I can factor out a negative 1 here, and by factoring out a negative 1, I'm left with an x minus 1. And now I have common terms that divide out, and this negative, you know, can just be brought up to the middle. It doesn't matter if you have, 4 divided by negative 2, or if you have a negative 4 divided by a 2. It doesn't matter where the negative is, you still have a negative 2, right? So we can take this negative now and just multiply it times x plus 4 times x plus 1. And there you go. So that is basically the idea of simplifying our rational expressions, is basically to work into simplifying using our different factoring techniques and then looking to apply the division property. And, basically we looked at grouping, we looked at factoring out common terms, difference of 2 squares, raising the power. There's a lot of different factoring techniques that we want to be familiar with for this. And then also, sometimes be careful, and there's not everything needs to simplify out, although I'm not sure if I meant to have anything wrong in with that one, but I guess I think it is. So in this case, things don't simplify out. And just remember that the division property only works across multiplication, not multiplication and not across addition and subtraction. So there you go. Now let's go ahead and look into the adding and subtracting.